Controlled bolting in an industrial setting is a critical job, and it requires high-precision torque tools. Enerpac offers a full line of torque tools. Today, we're going to be giving you an overview of how to use our flagship S3000X series hydraulic torque wrench, along with our fast ZU4 series electric pump, hydraulic hose, special reaction arms, BUS series backup spanner, and our BSH series sockets. Please note that this demonstration is not intended to replace your operator's manual. Please read and understand your operator's manual before you attempt to use any of these tools. The S3000X is Enerpac's premium square drive hydraulic torque wrench. It's made out of solid steel for greater durability. It also features a 35-degree rotation angle. That's actually a lot higher than most tools that are out there, and it allows the tool to perform faster. Over here we have a standard reaction arm which can be rotated 360 degrees. And on this side of the tool here, we see a push-button square drive. A positioning handle allows the operator to position the tool on the application and avoid potential pinch points. We'll be powering this wrench with our high-speed ZU4 Pro Series electric pump. This pump features a digital display which shows pressure, torque, cycle count, and related information. What also makes this pump special is that it features an auto cycle mode. With that auto cycle mode engaged, the user can continually operate the wrench and the pump simply by keeping the advance button on the pendant depressed. All the system components here are designed to work together and are rated for 10,000 psi or 700 bar. Please make sure that whatever components you use are rated at minimum 10,000 psi or 700 bar. As we begin, we'll make sure that all the pressure in the system is relieved and that the pressure gauge is showing 0. Now we can connect the couplings. Note the male and female connections on each end. Pull the collar over the couplings and hand tighten. Attach the other end of the hose to the pump following the same process. Follow the torque specifications provided by a qualified engineering team. Make sure that the wrench is set to rotate in the needed direction. The direction of turn can be adjusted by switching the position of the square drive. To do this, simply push the release button on the opposite side of the square drive, pull the shaft out, and reinsert it into the other side of the tool. Then adjust the positioning handle. Mount the socket onto the 1-inch square drive and fasten into place using a pin and ring to keep the socket from falling off. Before we use our pump, we'll first verify that we have sufficient hydraulic fluid by checking the sight glass of the reservoir and ensuring that the fluid level reaches the sight glass. Controlled bolting must be performed according to the appropriate specifications. Oftentimes, those specifications will require multiple torque passes on a flange. We'll be applying this methodology today, and for the sake of our demonstration, we'll be using 1800 Newton meters as our specified torque. For the first pass, we'll be applying 600 Newton meters, or 1/3 of that full specified torque. In our second pass, we'll apply 2/3 of that number, and in our third pass, we'll apply the full specified torque of 1800 Newton meters. We'll be applying all of these passes in a star formation. And once that is complete, we'll be doing one final pass, this time in a clockwise formation, working our way around the flange at our full specified torque of 1800 Newton meters. In manual mode, a relief valve is used to adjust the pressure to the desired torque setting. Loosen the relief valve locking nut and turn the handle counterclockwise until there is a slight drag in order to reduce pressure. To select our desired units of measurement, we will toggle through the menu options by pressing the menu button. Once we reach units, we will use the up or down arrows to to toggle to Newton meters. To input our wrench, we will toggle until we reach the various wrench options. We will then use the arrows to toggle to our desired wrench, the S3000X. Slowly turn the handle clockwise to increase pressure until the desired value is displayed. Then, tighten the locking nut at the desired value. With our torque set, we're nearly ready to fasten. But before we do that, we need to set our backup spanner. Backup spanners are used to prevent the bolt or the nut on the opposite side of the fastener from turning while we're attempting to torque our fastener. Enerpac backup spanners feature two hex sizes. Now the flange that we're going to be using today has nuts that are 2 inches across the flats. So we'll be using the Enerpac BUS-03, which has a 2-inch hex on one side and 1 inch and 13/16 on the other. Now that our first pass is done, we will set our pump to 2/3 of our desired torque and make a second pass. This time, we'll use the auto mode feature of our torque wrench pump. To do this, we will toggle to the auto mode with the menu button, and using the arrow buttons, turn this on. Note that although we are not setting our torque with the relief valve, we will need to set the valve high enough to allow our pump to reach the target torque. Now we will repeat the same fastening process. This time, because we are in auto mode, we'll simply keep the advance button depressed and continue to torque until the fastener stops turning. With our second pass complete, we will set our pump to our full specified torque value and follow the same process to make a third pass, followed by a final pass made at the full specified torque in a circular formation. Now that we've completely torqued our flange, we'll show you how to break out or loosen a fastener. First, we set the required torque on our pump as before. We will continue to use the auto mode. Next, we will reverse the position of the square drive shaft as well as the reaction arm. Earlier, we had discussed the importance of selecting an appropriate reaction point and positioning our reaction arm securely against that point. However, in some applications, the best reaction point won't accommodate our standard reaction arm, either because it's too close or because it's too far away. In cases like this, Enerpac offers a number of different optional reaction arms, including the short reaction arms, extended reaction arms, and reaction tube extensions. This concludes our instructional video for today. For more information, please refer to your operator's manual or contact Enerpac.